Hello class, and welcome to a review on chemical naming and formulas. The point of this PowerPoint is to review naming for ionic compounds, covalent molecules, and acids. We're going to review how to write the formulas for ionic compounds, covalent molecules, and acids. And we're going to discuss the fact that you need to memorize the charges on the periodic table, which for the most part go with columns, some are kind of odd, and memorizing polyatomic ions. Let's start our review with ionic compounds. Now these are metals with nonmetals. So if you have an element from the right side of the periodic table with something from the left, it's probably ionic compounds, keeping in mind there are always exceptions to the rules. When you name an ionic compound, do not change the first word. The second word, change the ending to IDE. That's it. Sodium chloride. If it is a transition element, you need to use a Roman numeral, and this is because most of those have varying charges. Now, we never use Roman numerals for zinc and silver because they only have one charge, and you need to memorize those. Polyatomic ions, you have an entire sheet on these, the Essential Knowledge handout. In polyatomic ions, the atoms are covalently bonded, but as a whole, they have a positive or a negative charge. In case you notice, one of my dogs came to visit on this lesson. When you write the formulas for ionic compounds, what I recommend is that you start with a symbol and its charge for both, or the formula for the polyatomic ion and its charge. The charges must cancel out. One of the easiest ways to do this is to use the crisscross and reduce method. So if you have Mg2+, chlorine 1-, crisscross, MgCl2. If you have polyatomic ions and there's more than one, they must go in parentheses. So if you look at the example, Mg parentheses OH parentheses 2. And there is a weird one I want to point out. You're going to see it in the homework assignment. When mercury has a Roman numeral 1, the formula for that is Hg2 2+. If it's mercury 2, it's Hg 2+. I know, weird. In my opinion, covalent molecules are so much easier to write, both names and formulas. A covalent molecule is when you have a nonmetal with a nonmetal. Please remember, hydrogen is a nonmetal. There are diatomic molecules, and you need to memorize these: H2, N2, O2, F2, Cl2, Br2, and I2. And if you look at nitrogen, oxygen, fluorine, chlorine, bromine, iodine, it forms a little bit of a corner on the periodic table. So if you can memorize where the location is, it helps to remember those. For covalent molecules, we do not change the first word at all, but we do add a prefix, except we never use mono on the first word. Second word, change the ending to IDE and always add a prefix. And there are the prefixes listed there: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. And sometimes when you put them together, you'll have a double vowel. A lot of times we will drop one of those vowels, like tetra. Oxide is really just tetroxide, so drop the A. When you write the formulas, it's really easy. You just have to interpret the symbol with the prefix. So nitrogen dioxide. Well, nitrogen's N. Dioxide, 2 O's, NO2. Yes, it is that simple. Yes, it's that time again to review naming acids. It can be rough, but this flowchart will make it a little bit easier. First, take a look at your formula. Does it start with H? Is it aqueous? If the answers are yes, it's probably an acid. Now I want you to count how many elements are in the formula. If there are only 2, you're going to follow this formula: hydroblankic acid. The blank comes from the root of the anion. HCl, the anion is chlorine. The root of chlorine is chlor, so you get hydrochloric acid. Notice you always use hydro when there's only 2 elements. But if there's 3 or more elements, we don't use hydro. Instead, the name is based on the polyatomic ion. Look up the name of the ion or memorize them. Ate becomes ic, ite becomes OUS. And I remember it because you ate that? Ick. It works. So for example, H2SO4, SO4, the polyatomic ion is sulfate. We're going to change 8 to ic. Now this is weird. Instead of sulfic, we're going to add the UR back in, so sulfuric acid. Now there is one strange one, and that is HCN. We use hydro with this word, hydrocyanic. So it is a polyatomic ion. We do use the hydro. It's kind of a weird one. Let's look at one more thing, how to write an acid formula. It's actually easier than you think. The first thing you want to do is start with the anion, the negative charged piece of it. Note its charge, and then add as many H's as you need to balance out that anion's charge. For example, hydrosulfuric acid. We have the word hydro, so you know it's only 2 elements, hydrogen with sulfur. You look up sulfur, it's a -2. I'm going to need 2 H's, thus H2S. One other example, phosphoric acid. Now you don't see the word hydro here, so that means there must be a polyatomic ion involved. Work backwards. Ic goes with 8, so phosphate, you look up phosphate, PO4, it has a -3 charge. That means you need 3 H's, so you get H3PO4. Now we will spend quite a bit of time on 2 separate homework assignments reviewing how to write all of these formulas.